cosine theta x for my example would be what? 3 divided by the square root of 3 squared plus 14 squared plus negative 5. Good? And if you want to find cosine theta y, it's the same thing. You just change it to cy, and z is the same. Good? In 2 dimensions, i.e. we need to have the parameter distance, displacement, x or y, velocity, time, acceleration. That's all the physics. We're done with 80% of chapter 4. Do we know what displacement is? Do we know what velocity is? Do we know what acceleration is? In theory, and time, we do. So that's pretty much it. In other words, if I catch, could you catch this? So let's look at the marker properly, yeah, and if you throw it back, I'll try to catch it too, probably. Did you guys see? Did this travel from where I'm sitting to Jen, where Jen is sitting? Mm-hmm. Yes. So it traveled in that horizontal direction. What else did it do? It did go up and go down, and when it went back, it traveled horizontally and also traveled in the right direction. That's what we call motion in 2 dimensions. Cool? And we would like to describe it. So let's see if we can. So if I had an object that is not in the x direction, not in the y direction, but here. This is the location. Can I find how far away is it? I could do this in 2 ways. By saying you travel that many steps in the x direction, you travel that many steps in the y direction, or I could say it's about 10 steps straight forward at an angle of theta. So this location, this arrow, I'm now going to call it, it's a displacement r at an angle theta. So I'm going to define the displacement instead of x or y, I'm going to define the displacement r as r final minus r initial. Cool. In other words, if you don't see this, let's imagine I started from here and ended up somewhere in here. You guys agree? So I would say initially I was that far away, which I'm going to call R initial. Good? And then finally I was at this location, which I'm going to call R final. And the actual distance traveled is going to be R final minus R initial. Cool. I'm moving in 2 dimensions because here, let's assume my x location was 3 and 4. Here it's 6 and 9. Did I move in the x direction? Mm-hmm. Did my x value change? Mm-hmm. Yes. Did my y value change? Mm-hmm. So I moved in both x and y direction. There's nothing new. I'm just going to call it r. And since everybody is looking so scared about it, we are going to say we don't like r. We're going to write r as x I hat plus y j hat. And now everybody's happy. We know how to deal with x and y. Cool? We are going to define velocity. What is velocity? The average velocity is defined as the change in displacement with respect to time. Correct? And instantaneous, if you take the limit of this, instantaneous velocity is defined as the change in distance with respect to time. Right? You take the limit as t goes to 0. That should remind you of the definition of derivative, blah, blah, blah. We don't care. That's how we define it. And then I could just take this and say that v equals d over dt, and I could write r as xi hat plus y j hat, and then I could derive this, and this would be dx dt I hat plus dy dt j hat. And what is dx dt? Velocity in the x direction plus velocity in the y direction. So velocity in general in 2 dimensions would be by adding velocity x and velocity y, but how do we add? Just 1 plus 1 equals 2, or we're adding vectors? You're adding vectors, which means you have to be careful. And finally, you could differentiate v. You could say that a is dv dt, and by doing that, you would have a would equal dvx dt I hat dvy dt j hat, and then based on that, this would be ax I hat ay. In other words, we don't have to do anything special for motion in 2 dimensions. We could find all the variables in the x direction, all the variables in the y direction. At the end, we know how to add up vectors. Right? So if I want r, I'm just going to add x to y, and I use the Pythagorean theorem. If I want the final velocity, I'll find the velocity in the x direction, I'll find velocity in the y direction, use the Pythagorean theorem to add them up. I find the acceleration in the x direction, find acceleration in the y direction, and use the Pythagorean theorem to add them up. So I don't have to do anything new. All I need to do is take my old equation for motion in 1 dimension,